Hi boys and girls, welcome to lab number 3. This is exploring properties of various household chemicals. Today we are going to explore the properties of matter, and the matter that we are exploring are household chemicals. So today what you're going to need are a few things, and you can keep all these things set up for the bigger chemistry experiment that we're going to do in 2 more labs, okay? So what you're going to need is baking soda. I just want to show you something with baking soda. Baking soda does not dissolve in water. This is actually a mixture. It's not a solution because the baking soda is not dissolving in the water. So what I like to put water in the baking soda because I need it to be a liquid for me to test it. But I'd like you to have a spoon that you can kind of stir it around. You can kind of make it milky for a little while, and then it's gonna settle out and fall to the bottom again. But just have a spoon ready. So baking soda and water. I just put, you can see how much baking soda I put in there and how much water I put in here. This is vinegar. You can get this vinegar very cheap at the grocery store. I have apple juice right here. I have dish soap. I used the very last bit of dish soap that I had and I mixed it with water. So that's my dish soap. And I have water. A little bit later, we're going to add some other things. I want you to get milk of magnesia. This is a product that you can get for $1 at the dollar store, and it is it's a medicine that helps you with an acidy stomach. So we're gonna play with this a little bit later. You're gonna need lemon juice, okay? You're also gonna need these cups, and I also happen to have, and if you don't have these, that's okay, but I have pH strips, and you can actually get pH strips at Ace Hardware in the section, like the hot tub section of Ace Hardware, because when you have a hot tub, you always measure the pH. So these are pH strips, okay? And I know you guys played a little bit with pH with the Teton Science Schools. So there you have it. All right, boys and girls, this is the next process that I want you to do, okay? I want you to take your science journal and open it to a page, here's the spiral of your journal or the bind of your journal. So open it so you have 2 white pages, and I want you to start making this data collection chart, okay? So it says Cabbage Chemistry Data Collection Chart. And I want you to have 1, 2, 3, 4, 5 columns, and 1, 2, 3, 4, 5, 6, 7, 8 rows. Okay, I'm just gonna hold it here for a little bit so you can kind of see what I'd like you to do. Across the top, you're gonna write household substance, observations or properties, write both, okay? I want you to write hypothesis, which means to predict, and I want you to think if it's an acid, a base, or if it's neutral, okay? Results, I'm gonna have you write color and then a slash and pH, okay? And here we'll use the pH strips. All right, and this top one is conclusion. So I want you to write, was your hypothesis correct, yes or no? We're not going to fill all of this out today, but we're going to start filling this column out today, and maybe this column, okay? So down here, I want you to write water, milk of magnesia, baking soda, apple juice, vinegar, lemon juice, and we might play with bleach a little bit later, but when you play with bleach, you gotta be super careful and wear your safety glasses, because you do not want bleach in your eyes. You don't want to spill bleach on your fingers. See my pretty glitter fingers? You just want to be really careful with it. So this is what I'd like you to spend the next little bit of time making, okay? If you need to pause and make this, that'd be great. All right, the first thing we're gonna do is examine each of these materials or each of these chemicals and write down, we're gonna observe and write down their properties. So right here I have baking soda. And when I stir it, what color is it? It's white. So what I'm gonna have you do is I want you to write various, so find baking soda right here, and you're gonna say it's white. Maybe it's milky looking, okay? You can say powder does not dissolve in water. You could also smell it. It has no smell, really has no smell. So I just want you to write the properties down in each of these boxes, okay? So vinegar is, look, there's my vinegar. It's mostly clear. Where's vinegar here? Right, clear. Maybe a little yellowy sometimes. Maybe your vinegar is yellowy. Now vinegar, it's one of those things where you smell it. Ooh, I want you to tell me what it smells like. Smells sour, maybe, okay? It's liquid, okay? Kind of like water. All right. I forgot to say, the other thing I want you to do is, you see in this column it says you want to make a hypothesis and you want to predict if it's acid, base, or neutral. I want you to, once you examine these properties, I want you to just make a prediction. What do you think this is? Do you think vinegar smells or seems acidic, basic, or neutral? And I know we haven't talked about acids, bases, and neutrals, but you've heard the word acid. You know that acids are strong chemicals that can clean and destroy things. Maybe you don't know what a base is. We're going to talk about this more. I just want you to just make a guess what you think. So this baking soda, what's your guess? Do you think it's an acid, a base, or do you think it's neutral? I'm not gonna predict for you because I don't want to spoil the experiment, but circle one of these and you tell me which one you think it is. You're making a prediction right now. Same here. Is this acid, base, or neutral? Okay. The next one you're gonna examine is apple juice. Okay, this is old apple juice. It has some stuff in it. This apple juice has been around for a long time. We're not drinking it. I'm just using it for science. But it smells like apple juice. It smells like apples. So it's liquid, yellow, smells like apples, sweet. Okay, I bet you anything if you touched it, which I don't really want you to touch it, but it's probably a little sticky when it dries, right? Okay. Now I want you to write, oh, and predict. Do you think that's acid, base, or neutral? Circle one of those, okay? Here is my dish soap, okay? Dish soap. If I had put less in here, it would probably feel like, where's my dish soap? Ooh, I don't even have dish soap on here, do I? Oh, I forgot it. Darn it. You know what? I'm gonna put dish soap where bleach is. I changed my chart a little bit I put dish soap here and bleach here. So dish soap, I'm gonna say it's, let's see, can I write? It's purple. It's bubbly. It's kind of gel-like, right? And so these are my observations and my properties, and I'm gonna guess if it's acid, base, or neutral. Circle one of those. Okay. And finally, the easy one, water. What's water look like? It is liquid, clear, no smell. I think that's probably it. And I want you to predict, is it acid, base, or neutral? Okay, we're gonna do these a little bit later. I don't want to spoil the cabbage chemistry experiment that we're gonna do. So we'll observe them a little bit later, but we're not gonna test their pH today with the pH strips. All right, boys and girls, I decided to change my chart a little bit. I just want you to see, this is what we just did, okay? But over here, I changed it, and I'd like you to change yours, and I'm so sorry. You can rip this page off and start over again if you want, but I want 2 results columns. I want one results that has pH strips over the top of it, and it says color/pH, okay? And here I want you to write cabbage results color/pH. We're gonna use this one in another lab, but we're gonna use this one today, okay? So please change this part of your paper into 2 results columns, okay? Thanks. All right, boys and girls, now it's time to test the pH of these products, okay? I'm gonna just stir up my baking soda, and I'm going to put my test strip in. So you can see I got the test strips out and ready to go. And I'm going to just dip it in and pull it out and let it sit here. It turned a nice yellow color. It's actually changing as we go. Let's see if I can find you can see that it's kind of changing to a yellow color. All right, so kind of yellow green, it's starting to change green. Now I'm gonna put the vinegar one in. Oops, I have 2 strips here. And I'm going to dip that in. Ooh, totally different color. Okay. You can see that I have kind of a pinky red color. All right. Now I'm gonna dip apple juice in. See what happens here. It's a little bit lighter pink. Pinky red. Okay. Dish soap. Let's see what we're gonna do here. Ooh, dish soap is more yellowy, greeny. We'll see what happens to that one. And water. Let's check out water. Okay, water is not changing color that much. Interesting. Okay, so now let's look at this. So I'm going to show you this pH scale. And I think you guys have done this with the Teton Science School, as I should have gotten this ready beforehand. But here's my little pH scale. Okay, you can see this scale here. And right here it says that this kind of green, this blue color has a pH of 1, which is very acidic. And over here, there's a pH of 14 in this kind of purpley dark color, okay? And so now what I wanna do is compare to see anything in this top row is a more acid, and anything in this bottom row is more basic. So where would you put this baking soda? It's looking like it's around a pH 8. So it appears to be more of a base, okay? So in your column, and I can't show this to you right now, but I'll show it to you in a minute. I'm gonna find baking soda. I'm gonna write green, yellow, which indicates that it's a slight base, okay? So you can see in my column, I wrote green, yellow, and it's a slight base. All right, baking soda. Let's look at the vinegar strip, okay? And I have it up against the white so we can see it better. Ooh, so can you see? It's kind of hard to match it on the computer, but it looks like it's a pH of 2, so it's highly acidic, okay? So we've got vinegar, which is kind of a, let's say it's a red-orange. I'm gonna find my vinegar and I'm gonna write red, orange, and I'm gonna say that it's an acid, okay? Apple juice. Apple juice is looking like it's around that number 4. Does it look like it's that number 4 to you? So it's around that number 4. So I'm gonna say that it is orange. Apple juice is orange, and it's an acid. All right. Dish soap. Okay, let's see where dish soap is. Dish soap looks pretty neutral, doesn't it? Looks like it's kind of around the 7. So if anything, it's maybe slightly acidic. It's a little greenish. So we might just call this one maybe a neutral. Dish soap. Where's my dish soap? It's down here. I'm gonna say that it's yellow and it's neutral in this case. Ooh, the water, very interesting. This water almost looks a slightly basic. It has some green to it. So, but it's also very yellow. So water tends to be neutral, but there can be basic water and there can be acidic water.
Mommy.
That's my son
Mommy.
calling.
Mama.
All right, guys. My son called while I was teaching, but I just want to show you this chart that we filled out. We did the water. Which one was that? We did baking soda. We did apple juice. We did vinegar, and we did dish soap. So I'm hoping your results will be in. So the next thing I'd like you to do is I just want you to observe the properties of this milk of magnesia. And you actually, sometimes you need to stir this up. So I can't find my lid, but I'm gonna kind of stir it up because it settles a little bit. And I just want you to pour enough in and just observe the properties. It's very creamy. It sticks to the sides. It's milky. So I want you to write this down in your chart. So milky, creamy, white. Does it smell? This one doesn't smell. Some milk of magnesia smell minty, but there's no smell. Okay. And I want you to predict, do you think this is an acid, a base, or it's neutral? This is a medicine that helps when you have an acidy stomach. You know, when you have movie theater belly, you've eaten too much candy and popcorn and your stomach really hurts. Milk of magnesia can help with that kind of belly. So predict if you think that's an acid, a base, or a neutral. Okay, you've got that. And the next thing I want you to do is take some lemon juice, and I want you to write the observations down of the lemon juice. Let's see here. I'm gonna put just that same amount of lemon juice in. Okay, lemon juice. Ooh, it's opaque, which means it's kind of milky. It's not really milky, but it's not clear. So it's opaque. It's yellow. And let's smell it. Ooh, smells lemony. Smells lemony. Smells strong. It makes your eyes water. Okay, so I'm just writing my properties. And I want you to predict, do you think lemon juice is acid, base, or neutral? Okay, so here we have all of our substances, and we did all of our observations in our properties. And that is it for Lab 3, exploring the properties of our household chemicals. Bye, guys. Really quick, I just want to tell you that you can save all of these glasses. So put them on the counter somewhere, save them. Don't mix anything just yet. We can use this stuff for our experiment a little bit later. And I'm probably going to send that video tomorrow. All right. So please save all of these things because we're going to use them in our experiment tomorrow. All right. Bye.